All right. So, uh, frequencies, they're kind of a big deal. And today we're taking a deep dive into them.
They really are.
Yeah. And, they're everywhere, right?
Yeah.
Like, I mean, just think about it. Everything from the hum of your laptop to, I don't know, like the rhythm of your heartbeat.
Exactly.
It's pretty amazing when you think about it.
It is. And it's something that we don't often stop to think about. But when we do, it's pretty mind-blowing.
Yeah. And one of the things that I find really interesting is the way that frequencies tie into music and even how we move. Like you sent over some research on this.
Right.
And there was this interesting bit about the suggested frequency for IsoTone massage movements being 5 hertz.
Right.
Which this also seems to be connected to how some animals move naturally.
Yeah, that's right.
So I'm really curious to dig into that a little bit more.
Yeah, absolutely. So, what's fascinating here is that everything vibrates at its own natural frequency. It's like a fingerprint for objects and even living things, And when it comes to animal movement, this frequency is influenced by factors like their size, bone structure, and even muscle type.
I see.
Think of it like a pendulum. A longer pendulum swings more slowly than a shorter one.
Oh, okay. So a larger animal, like say an elephant, would have a slower natural frequency of movement compared to a smaller, quicker animal, like a squirrel.
Precisely. A large elephant might move at a frequency of around 0.5 to 1 hertz, which is pretty slow.
Wow.
On the other hand, smaller animals tend to move much faster. Take a sparrow, for instance. Their wings beat at about 10-15 hertz.
Really?
Yeah, that rapid flapping is what allows them to achieve lift and maneuver so deftly.
That's incredible. And this connection between size and frequency,
Yep.
it's consistent across the animal kingdom.
Yes, largely. A large fish, like a shark, might swim at a leisurely of 0.52 hertz, while a tiny hummingbird's wings could buzz at an astonishing 50 hertz, enabling them to hover. It's incredible how nature has optimized movement across such a vast spectrum of frequencies.
That's amazing. Like, really makes you think about how everything is interconnected.
Right.
Speaking of connections, where does music fit into all of this? I mean, we experience music through sound, which is itself a form of vibration, right?
Absolutely. Music is essentially organized sound, and sound travels as waves with specific frequencies. A higher frequency creates a higher-pitched sound, while a lower frequency results in a lower pitch.
Right, like the difference between a deep bass note and a high-pitched flute.
Exactly.
But what about tempo, the speed of the music? Does that relate to frequency as well?
It certainly does. Musical tempo, which we often measure in beats per minute, can actually be expressed in hertz. For instance, a slow largo tempo, typically marked at 40-60 beats per minute, translates to about 0.67 to 1 hertz.
So when a composer writes largo, they're essentially specifying a frequency range for the music, even if they don't explicitly use the term hertz.
That's a very insightful way to put it. As the tempo increases, so does the frequency. A lively allegro at 120-168 beats per minute would sit around 2 to 2.8 hertz, and a super fast prestissimo that could easily exceed 3.33 hertz.
Wow. So when I'm listening to a fast-paced dance track, I'm actually experiencing sound waves vibrating at a much higher frequency than when I'm relaxing to a slower, more meditative piece.
Exactly. It's not just your ears perceiving the tempo. Your entire body is literally vibrating along with those sound waves.
This is really making me rethink how I listen to music. But if we can experience music at all these different frequencies, what about the musicians creating it? Are there physical limits to how fast they can play those notes? Especially considering our fingers can only move so fast.
You've hit on a fascinating point. Our neuromuscular system, which controls our movements, does have limitations in terms of how fast it can send signals and produce movements. Generally, our fingers can only produce individual movements at a rate of about 8 to 12 hertz.
So even the most skilled musician is ultimately bound by the speed of their nerve impulses.
That's right. But what's remarkable is how musicians have developed techniques to overcome these limitations, at least to some extent. Techniques like tremolo picking on a guitar or rapid trills on a piano allow them to produce a flurry of notes that can exceed 12 hertz.
So it's not just raw speed, but strategy and technique that allow them to achieve these incredibly fast passages.
Absolutely. By mastering specific techniques, musicians can essentially hack their neuromuscular limitations to create incredibly fast and complex musical passages.
I'm starting to see music in a whole new light. And I can't help but wonder, does the type of instrument also influence the achievable frequencies? I mean, it seems like a violin bow could move faster than, say, a piano hammer.
You're right to think about the mechanics of the instrument. Take the violin, for example. Skilled violinists can use techniques like spiccato and sautelé, producing sound frequencies up to 10-12 hertz.
So like how about piano playing? I imagine there are limits with how quickly the hammers can strike the strings.
Yeah, for sure. While a piano hammer striking a string, it happens much faster than, say, a bow stroke. The limiting factor really becomes the speed at which a pianist can move their fingers between keys.
Right.
For repeated notes on the same key, skilled pianists can hit 8-12 hertz. But for those impressive trills where they alternate between two keys, they can sometimes reach 10-15 hertz.
Wow. So it seems that even with instruments capable of producing sounds at faster frequencies, we're still bound by those neuromuscular constraints.
Yeah.
It's a fascinating interplay between human capability and the physics of the instruments.
It truly is. And it highlights how musicians aren't just playing notes, but pushing the boundaries of what's physically possible to create music.
Yeah.
It's this incredible blend of artistic expression and the scientific principles of sound.
Okay, so we've talked about the frequencies of animal movement and how those relate to musical tempos.
Right.
But I'm curious, is there a deeper connection there? Is it just a coincidence that these ranges overlap, or is there something more fundamental going on?
That's a question that has intrigued scientists for a long time.
Yeah.
There's a field called biomusicology that explores the biological and evolutionary roots of music. Some researchers believe that our preference for certain musical tempos might be linked to the rhythms we've evolved to hear in nature.
Oh, interesting. So are you saying that we might find certain tempos pleasing because they remind us on some level of sounds our ancestors would have heard in their natural environment?
That's one theory. Think about the sound of waves crashing on a shore.
Okay.
The rhythm is often around 0.5 to 2 hertz, similar to the tempo of a calming piece of music.
Yeah.
And that whooshing sound could be seen as a natural form of white noise, which many find relaxing.
That makes sense. It's almost like those sounds became ingrained in us over time, shaping our perception of what sounds pleasant or calming. What about the other end of the spectrum, those fast-paced tempos that get our hearts racing?
Well, imagine our ancestors hearing the rapid chirping of a bird signaling danger.
Okay.
That kind of sound would trigger a fight-or-flight response, preparing the body for action. Perhaps that's why we still find fast, high-pitched sounds alerting and sometimes even anxiety-inducing.
It's incredible to think that our musical preferences might be influenced by sounds that our ancestors heard millions of years ago. But what about those super fast tempos in music that seem to go beyond what we normally encounter in nature? Do those fit into this evolutionary perspective?
It's true that the frequencies produced by some of those extreme musical techniques, they push beyond the typical range of natural sounds.
Right.
However, there's still a fascinating connection to our biology at play. Remember how we talked about our fingers having a limit on how fast they can move?
Yeah.
Well, when we hear a musician playing at those seemingly impossible speeds, it triggers a sense of awe and amazement, almost like witnessing a superhuman feat.
It's like they're defying the limits of what we thought was physically possible.
Exactly. And that feeling of awe can trigger the release of dopamine, a neurotransmitter associated with pleasure and reward. So even though those super fast tempos might not have a direct equivalent in nature, they still tap into our brain's reward system, making them exciting and enjoyable to listen to.
It's like music has this hidden power to unlock ancient instincts and emotions within us. But it's not just about tempo, right? The research you sent also mentioned that these specific frequencies of musical notes themselves can have an impact on our emotions and even our physiology.
You're absolutely right.
Okay.
For example, some studies suggest that listening to music in the key of C major, which tends to have a brighter and more cheerful quality, can increase heart rate variability, a measure of the heart's ability to adapt to change.
So are you saying that listening to certain types of music could actually have a positive impact on our cardiovascular health?
It's a possibility that researchers are actively exploring. More research is needed, of course.
Right.
But it's an intriguing area of study. On the other hand, music in a minor key, which often evokes feelings of sadness or melancholy, might have the opposite effect, slowing down the heart rate.
It's almost like music can tune our bodies like instruments themselves. This makes me think about the concept of IsoTone Massage and how it utilizes a specific frequency of 5 hertz. Is there any connection between that and what we've been discussing about music and animal movement?
It's interesting to consider that 5 hertz does fall within the range of many natural movements we've discussed, like a cat wagging its tail or a medium-sized bird flapping its wings. It's a frequency that our bodies are already familiar with.
So perhaps there's something inherently soothing or recognizable about that frequency, which could explain why it's used in isotone massage.
That's certainly a thought-provoking idea. It highlights how even seemingly disparate fields like music, animal movement, and massage therapy can intersect through the power of frequencies.
This has been an incredible journey through the world of frequencies. We've covered so much ground, from elephants to hummingbirds, from largo to prestissimo, and even touched on how certain frequencies might impact our well-being. But I know we need to wrap things up soon. What final thought do you want to leave our listeners with today?
I think the biggest takeaway is that frequencies are everywhere, constantly shaping our world and experiences in ways we're only beginning to understand.
Yeah.
From the symphony of nature to the melodies within our own bodies, these vibrations connect us to the past, present, and future in profound ways.
Okay, so we've been like totally immersed in this world of frequencies, right?
Yeah, it's been quite a journey.
And it's like mind-blowing how this like invisible force shapes so much of our experience.
Absolutely.
You know, we've gone from like elephants to hummingbirds,
Yeah.
largo to prestissimo,
Sin, a range.
and even touch on how certain frequencies might impact our well-being.
Mm-hmm.
So as we like wrap up this deep dive, is there a final thought you'd like to leave our listeners with?
You know, as we kind of conclude our exploration, I'd like to leave a listener with something to think about.
Okay.
Now that you're more aware of this whole idea of frequencies, take a moment to just listen to the world around you.
Yeah, like really tune in.
Yeah, tune in to the hum of your refrigerator, the chirp of birds outside your window, the rumble of traffic in the distance.
All those everyday sounds.
Exactly. These are all just expressions of frequency creating the symphony of sound that surrounds us every day.
It's like we're swimming in an ocean of sound.
Yeah, and as you become more aware of these frequencies, ask yourself, how does this awareness change your perception?
That's a good question.
Do you start noticing patterns or connections you hadn't before?
Yeah, like maybe you find yourself tapping your foot to the rhythm of a passing train, or feeling a sense of calm wash over you as you listen to the gentle rustling of leaves.
Exactly. Or maybe you start to recognize the frequencies in music that resonate most deeply with you.
Oh yeah, the ones that evoke specific emotions or memories.
Exactly.
It's powerful stuff.
It really is.
So as we wrap up, I guess the takeaway is that the world is like this incredible symphony of frequencies.
It is.
This vibrant tapestry woven together by these invisible vibrations.
Yeah, and it's a symphony that's constantly playing, whether we're aware of it or not.
That's a great way to put it. So to our listeners out there, keep exploring, keep listening, and keep discovering the amazing ways in which frequencies shape our world and our lives.
Well said. And until next time, may your ears be open and your mind curious.
Couldn't have said it better myself.